Hey guys, how's it going? Hope everybody's doing well and staying safe. We're going to continue on for the next section here for TSW 8-9. This is about acids and bases. So before we get too far into this, I want to draw your attention to a couple of things here. What acids and bases are comprised of. So first and foremost, we have a couple of things that should look familiar. You have your hydrogen ion here and your OH ion. So first of all, when you mix a hydrogen ion and a hydroxide ion together, what do you get? Well, you take a hydrogen, that's +1, plus hydroxide, OH, which is -1. What does that make? It makes H2O, which is water. So that's a key distinction moving forward as we go over acids and bases. So to clarify, properties of acids. So acids are types of chemicals that technically have a sour taste, such as a lemon. They react with metals and carbonates, which are carbonates, as you guys remember, is CO3. Litmus paper is a type of indicator. It's basically a little piece of paper that has some chemicals on it, and it's a blue piece of paper, but when it comes in contact with an acid, it turns it red. And so you don't need to know the type of acid or what acid it is with this particular test. It's just a indicator. It just lets you know what it is. It's either an acid or not. So the technical term, which we'll get into a little bit here, is any substance that produces a hydrogen ion or what's called hydronium. That's H3O in water. So if you put this substance in water and it produces hydrogen ion or hydronium, it's technically an acid. All right, so apologize for the conversion here. When I uploaded this PowerPoint into this program, it changed a couple of things. So you guys know this is supposed to be a yield sign, right? All right, so there you go. So acids in solution, this is a very simplified version. So if you take an acid like hydrochloric acid and you put it in a solution of water, what's going to happen is it's going to break apart, decompose to hydrogen ion and chlorine ions in the solution. It's going to dissolve. It's going to give off a lot of heat too, but nonetheless, that's what it is. So the other one example here is H2SO4. Like I said, this is supposed to be a subscript. You guys know that. It will turn into, you put it into water, it's going to break into 2 hydrogen ions plus the SO4 negative ion here. So that's what happens when you put acids into water. It dissolves, it breaks apart into this ionic form. Now, bases are the opposite of acids in a lot of ways. They have a very bitter taste. If you've ever gotten soap in your mouth, you know that. They feel very slippery. You put soap on your hands and rub your hands together. It is slippery for sure. And they have an indicator test as well. You have a red litmus paper. I'll show you guys some of this when we come back to school. This red paper that has a chemical on there, when it interacts with a base, it will turn it blue. So this is a color indicator. And the technical term here for a base is when a substance produces OH, hydroxide ion, when you put it in water. Once again, this is supposed to be a yield sign. So sodium hydroxide plus sodium plus, when you put it in water, it produces sodium ion plus hydroxide ion. All right, and down here, calcium hydroxide. Once you put that in water, it produces calcium plus 1, 2 ions of hydroxide. So there are several different types of acids and bases, and we usually classify these according to their strength in terms of how well they will dissolve things or how well they will interact with different compounds. So we use the term strong when an acid or a base is extremely concentrated, full of hydrogen ion or OH ion. If it has a lot of those particular ions, it will be classified as a strong acid or a strong base. Weak is a term that we use for when you have a low concentration of hydroxide or hydrogen ions. So they lots of weak acids and lots of weak bases that you come in contact every day. You have weak acids and weak bases in your foods, lots of different liquids that you drink. High concentrations can be very dangerous, so strong acids and strong bases are very hazardous to humans. So for instance, if you were to get a very strong acid on your skin, it will cause the water to basically rush out of all your cells, and it will damage the proteins that are in your cells, and this is an irreversible change. And so the high concentration of acids can be very dangerous, and they have to be handled very carefully. So if you see here, you have a list of different acids and bases here. Your strong ones. These are all, if they have a high concentration, could technically be classified as strong, but you have hydrochloric acid, nitric acid, sulfuric acid, carbonic acid, acetic acid, and phosphoric acid. So if you notice that all acids had something in common here, which is they all have an H at the beginning of the formula, right? And so they're all technically ionic type of compounds where they have positive and negative ions that are bonded together, all right? So your bases over here are, if you notice, they are sodium hydroxide, potassium hydroxide, calcium hydroxide, aluminum hydroxide, ammonia, and calcium oxide. Now these all have hydroxide in the name, so that's pretty good indicator that it is a base just based on the name and in the formula. So ammonium and calcium hydroxide are two unique bases because even though they do not have an OH molecule, an OH ion in their formula, once they are put into water, they break apart and form hydroxide in a solution. So this is why they're technically classified as a base. Okay? So we're going to work more of these here shortly. So the pH scale is basically a scale which we measure the strength or intensity of different acids and bases. It's based on a scale of 0 to 14, okay? And the 0 here indicates a very, very strong acid, and 14 is a number that indicates a very, very strong base. Now notice what's in the middle, water, right? Water is technically, has a pH of 7, which is what we call neutral. Neutral is neither an acid nor a base. It's right there in the middle, okay? So the strong ones have a higher concentration of hydrogen or hydroxide, and they're located, the strong ones are, acids are closer to 0, the strong bases are closer to 14. Things that are in the middle range here, we would call these weaker acids or bases. All right, So if something has a pH of 2, we know that's a strong base. If it has a pH of 12, it's pretty much a strong base. The pH of 2, sorry, that's a strong acid. So here's a nice little chart that gives you an idea of what different substances, or how their different substances are classified. So as you can see here in the middle, you have your pure water, which is a pH of 7, sea water, which is a pH of 8. All right, and baking soda has a pH of about 9. Soapy water has a pH of about 12. Bleach, oven cleaner, these sorts of harsh chemicals, these are in your strong acid range here. So on the opposite side, you know, saliva in your mouth or urine has a slightly acidic, and that is 6. Black coffee would be a pH of a 5. Lemon juice, vinegar, these sorts of things are in the 2 to 3 range. Hydrochloric acid in your stomach is about a 1. That's a strong acid. The reason why the hydrochloric acid doesn't dissolve your stomach is because you have mucus in your stomach, which protects the lining of your stomach from being damaged by the hydrochloric acid. So what happens when you mix these two substances together is what we'll go over next. So when you mix an acid and base together, it forms a specific kind of reaction called neutralization. All right, an acid and base mixture, when they're mixed together, it forms a solution that is, shall we say, less like the two of those. So for instance, if you have a pH of 12 solution and you mix that with a pH of 2, it's basically going to meet somewhere in the middle, around 8. All right? So if you have a scale of 0 to 14, you have something that's about a 12, and you have something that's about a 2. You mix them together, whatever that halfway point is, that's going to be around what the neutralization reaction will produce. So we'll go over this more in detail in class. So last but not least, you have the neutralization reaction. This is the next type of reaction, the 6th reaction that we'll learn this year. So you have an acid plus a base yields salt plus water. Now salt is a term that basically means any type of ionic compound produced by a neutralization reaction. In other words, it's going to be an ionic compound that's produced by an acid and base being mixed together. So for instance, here's a great example. You have hydrochloric acid plus sodium hydroxide. You have sodium, it produces a salt, which is NaCl plus your water. So this is the neutralization reaction. So reality, your hydrogen from your acid and your base, your hydroxide from your base, are producing the water. And the positive ion from one and the negative ion from the other are producing your salt. So this is really a type of double replacement reaction, but with specific types of products and reactants. So if you look on page 244, you'll see a list of types of salts. So take a look at those and we'll go over those more shortly. So this is it for this particular video. So I would like you to watch this. We'll review. We'll go over this in class today. And you'll have this. We'll do an activity with this on Wednesday. Take care.